In this lecture, we are going to study node voltage analysis. In the previous lectures, we studied KCL and KVL rules to find the unknown voltages and current. But in KCL or KVL, the number of equations to be solved simultaneously is very large. For example, if there are 6 elements in a circuit, then there will be 6 unknown equations for the current and there will be 6 unknown equations for voltage. So we will have to solve 12 equations simultaneously to find the unknown voltage and current. So to reduce the number of equations, we are going to use another method known as node voltage analysis to find the unknown voltages at these nodes. And when we will find the voltage at these nodes, the voltage across the element can be found using the rule which I am going to explain. In this circuit there are 4 nodes. This is node B, we can consider it D. This is node A, this is node B, and this is node C. One node is considered as a reference node and we consider the voltage at that node is 0 volts. And the voltage at these nodes will be evaluated with respect to this reference node. So we can see there are two kinds of elements that are connected between this node and this node. If an element is connected between ground and a node voltage and a node where we know the value of the voltage, then the voltage across this element V1 will be equal to VA. But if an element is connected between two nodes VB, for example, and VA, then the voltage across this node will be equal to VA minus VB. If this is plus, this is minus. Let's solve an example to understand this concept, how we can find the element voltages knowing the voltage of the nodes. This is an example and these are the 3 nodes VA, VB and VC. We know the voltages at the nodes, we want to find the voltage across these elements. So V1 will be equal to, V1 is connected between two nodes. Using this principle we will subtract this voltage from this voltage. V1 will be equal to VA minus VB. VA is equal to 5 volts minus VB is equal to 10 volts. So it will become minus 5 volts across V1. Now we will find V2. V2 will be equal to, this is plus sign, so VA minus VC. 5 volts minus 3 volts, it will become 8 volts. Similarly, V3 is equal to VB minus VC. V3 is equal to VB minus VC. VB is equal to 10 volts minus 3 volts, it will become 13 volts. V4 is connected between VB and the reference voltage. This principle will be used. So V4 will be equal to VB minus ground voltage is 0. So VB is equal to 10 volts. V5 is equal to, this side is positive, so 0 minus 3 volts. So it will become plus 3 volts. We will consider the volt at the positive side first minus the voltage on the negative side. Let's see what are the steps to find the node voltage. This is a circuit. We will solve this circuit and we will see what are the steps to find the node voltage. There are 3 nodes in this circuit. This is a node A, this is node B, and this is node C. I considered it as a reference node and it is grounded. According to this node, we will find the voltage at this node and this node. So let's see what are the steps. First of all, we will use KCL. We will apply KCL at these nodes and we will write the KCL equation for the node for these nodes. Let's consider this is current I1, this is I0, and this is I2, and this is I3. So all the three currents are leaving from these nodes, so we will consider them as negative, minus I0, minus I1, minus I2. Algebraic sum is equal to 0. This is node A. Similarly, at node B, two currents are there. One current is entering current, we will take it as positive, I2, minus I3 is leaving, we will take it as negative, and the sum is equal to 0. Now we will find the value of these currents in the form of voltage using the Ohm's law. V is equal to IR. So I0 is equal to minus IS, because source current is in this direction and I0 is in the opposite direction, so I0 is equal to minus IS. I1 is flowing from this resistance R1, so according to Ohm's law, we can say I1 is equal to V over R. V voltage is VA across this resistance divided by resistance R1. This is I1. I2 is the current flowing through this resistance, and the voltage across this resistance is VA minus VB. VA minus VB divided by R2. Similarly, I3 will be equal to VB divided by R3. This is R2. Now we will put the values of I1, I2 and I3 in these equations and convert these equations in the form of node voltage VA, VB, which we want to find. Now we will put these values in this equation. In node, if we put the value of I0, I1 and I2 from these equations in this equation, this equation will become minus I0 is equal to minus IS, minus I1 is equal to VA over R1, and minus I2 is equal to VA minus VB divided by R2 is equal to 0. This will become positive IS, and we will take both these terms on the other side, so they will become positive VA over R plus VA over R2 minus, we will separate them in the denominator, minus VB over R2. We can take VA common from this, VA into 1 over R1 plus 1 over R2 minus 1 over R2 VB, and this is equal to IS. So this equation is converted into the form of node voltages VA and VB. Resistances are known, the source current is known. Similarly, we will convert this equation using the value of I2 and I3. We have converted this equation that was in the form of current into the equation that has the unknowns VA and VB. Similarly, we will convert this equation using the value of I2 and I3. So putting the value of I2 and I3 in this equation, I2 is equal to VA minus VB divided by R. This is the value of I2 minus I3 is equal to VB divided by R3, and this is equal to 0. So separating the denominator, VA over R2 minus VB over R2 minus VB over R3 is equal to 0. So VA into 1 over R2 minus VB can be taken common, 1 over R2 plus 1 over R3 and it is equal to 0. So this equation is also converted in the form of VA and VB. So these are the two equations that has the unknown VA and VB. This VB is in minus, we can convert it into positive by multiplying the equation with the minus 1. So it will become minus 1 over R2 and this will become positive. Now we can write these two equations in the matrix form like this: 1 over R1 plus 1 over R2. The coefficient of VA is written here. Similarly, the coefficient of VB is minus 1 over R2 and coefficient of VA in the second equation is minus 1 over R2 and the coefficient of VB is equal to 1 over R2 plus 1 over R3. This is the matrix of resistances and we have VA and VB here and it is equal to IS and 0. This is, we can consider it as AX is equal to B. We want to find X will be equal to A inverse B. So using these steps you can find the unknown voltages VA and VB. I hope you will have got understanding of node voltage analysis. In the next lecture we will try to solve an example using node voltage analysis. Thank you.